Radiometric dating. In the last presentation, we learned about the process of radioactive decay, where an isotope of one element decays into an isotope of another element. After a quick review, we will learn how scientists use this process to estimate the age of rock layers in the geologic column. One example of radioactive decay is the parent isotope rubidium decaying to form the daughter isotope strontium. This decay process from each parent isotope to daughter isotope occurs at a known steady rate called the half-life. This table shows the half-lives of several sets of parent and daughter isotopes. In this example, you can see that the half-life of rubidium-87 is 48.8 billion years. This curve shows that with each half-life, half the remaining parent isotope decays until it is too small to measure. You can think of the area under the curve as the ever-decreasing amount of the parent isotope. But remember, it doesn't just disappear completely, it turns into daughter isotope, which is represented by the increasing area above the curve. So at any given place on the curve, a certain amount of parent product and a certain amount of daughter product make up the whole sample. In the process of radiometric dating, scientists measure the amount of parent and daughter isotopes in a rock sample. Then they compare the measurements to see how many half-lives of decay would have produced that ratio of parent and daughter isotopes. Let's say that a sample is found to be half uranium-238, which is the parent isotope, and half lead-206, which is the daughter isotope. Half of each would mean that one half-life had passed. Since the half-life of uranium-238 is 4.5 billion years, the sample's age should be about 4.5 billion years. Notice how the bar that represents uranium and the bar that represents lead meet at the location of one of the red dots, which indicates how many half-lives have passed. Now let's say that only 1/4 of the sample is parent product, like uranium-238 again, and 3/4 of the sample is its daughter product, lead-206. As we slide the bars to the right, watch to see when the place where the two bars meet lines up with one of the red dots. Because it lines up with one of the red dots here, that indicates that 2 half-lives have passed. Since the half-life of uranium-238 is 4.5 billion years, twice that would be 9 billion years. In real life, samples are more likely to be between exact half-lives, which just means that the scientists have to do math that is a little more challenging in order to calculate the age of whatever material they are dating. Radiometric dating methods are used mostly to date igneous rocks, like granite, for example, which are formed when magma or lava cools and solidifies. Radiometric dating is not used to date sedimentary rocks, like sandstone, shale, and limestone. Since most of the geologic column is made up of sedimentary layers, where do geologists find the igneous material to try to date? Wherever anything from a volcano has been preserved in the rocks. Sometimes lava flows over an existing sedimentary layer and then is covered by another sedimentary layer. While the sedimentary layers cannot be used for radiometric dating, the lava layer can. Other times, magma that is still underground can push its way into or between sedimentary layers. Preserved layers of volcanic ash can also be used for radiometric dating. These things are widespread enough throughout the geologic column that geologists have been able to calculate the dates suggested by the geologic timescale. Just how accurate is this process for determining how old rock layers and fossils are? Find out in the next presentation.